Okay, we're going to talk about making a drawing. And if you follow the Autodesk U class on lesson 6, they'll show you how to make a drawing. So in this case, we have a part here that's been designed, and you need to make a drawing in order to make it yourself or give it to somebody else to make. Maybe it's a manual machining project, or but some kind of paperwork that'll go with the job, and that could be even the CNC side. You know, if we're using Titan blueprints. Now, if we make our own parts, we're going to
You have 15 minutes left of computer time.
I'm getting kicked off. Okay. So in here, we're pretty much only using design, manufacture. Now I'm going to go drawing from design. All right, right up here says create new drawing. I'm going to supply new templates here, right here. We're just going to do from scratch for now. Drawing templates, even in SolidWorks, is like what's the blueprint going to look like. So, okay, I'm going to hit OK, and another window should pop up. And I'm going to close this one. Oh, shrink that one. Okay, now we got drawing view. And right there says STC Precision Machining, and it's going to put the name of the file in there. And by default, it's trying to place something somewhere. So this is front view. I really like to use top view. You can use either one of these. Now we have top view. This is too small, so we got to change the scale. Go 1:1. All right, that looks pretty good. Now in blueprints, the standard view is what we call a 3-view print, which would be front, top, and right side in the United States. This one only really requires 2 views. Sometimes 3. It's like what's most beneficial. And then you try to put an isometric view in the corner. So we got to kind of work in this area here. So we can put like 2 views this way and the isometric up this way. So I'm going to place this right about here and hit OK. Notice it doesn't become a solid anymore. You can make it a solid or not, but I'm going to leave it in this format. And that's base view. Now we need to do a projected view. I got to select the parent and put it up here. Now these line right up with each other. Now even if you're doing old school paper drawings, you have to always be in line with the object. All right, that's that one. And while I'm at it, I'm going to put the isometric over here. See, and that's pretty much the form we want. Hit enter. Now this one's got hidden lines and stuff in it. So this one I want this one to be a solid. So I go back and edit the view, and it gives me styles right here. I want the solid one. Hit close. So you can play with all this stuff. And then we'll get into the what we call the title block down here. So this one has hidden lines, and this kind of helps your like looking at the front here. Are these through holes? I mean, yes they are, because you can see them, they're through with the hidden lines, or you can describe them. So a real basic thing is size. What size is this? So up here we have, these are descriptions: center line, center mark. You're going to use this one a lot, dimensioning. And you get specific dimensioning, but I'm just going to pick dimensioning by itself. So I'm going to click that line and that line right there. So it's 5.75 inches. This line and right there. Okay. Now I'm looking at this, I think these look kind of small. I'm going to go over here. Let's see, sheet settings. We got title block, sheet size, document settings right here. Come on. Text height. Click on this, and now this pops up. You get some defaults here. We're going to put 240. Hit OK. And now these get bigger. I'll get later about talking about the difference between 4, 4.0, 4.00. They're all the same number. Yeah, it's really communicating tolerance.
You have 10 minutes left of computer time.
I know, I'm getting kicked off again. But this will be a good starting point. So we got length, width, and we want height or thickness. We're going to go back here. And I'm going to do this one and this one here. That's 0.25 tall. So if you had to go get material, you can go right at it, and you probably want to describe the material. So if I went text and wrote down here, aluminum, right? Now I know what it is, right? Aluminum, there's a lot of information there. What size is that hole? I want a diameter dimension for this one. Click on this one, and I got to find a nice place to put it. A big goal in print drawing is not make it easy to read. Let me pick this one here. Now this one, I don't need to click on all of them, because if these are all the same, I just need to add a comment here. 5 places. Let me just pull this out a bit right there. All right. So that's a common term of it's located 5 places, and that would apply to these holes too. And then we want to have dimensions for how do we get to the first hole and all that kind of stuff. So I'll show you techniques like in this particular one. I'm going to save this one now, right? I'm going to hit File, Save. Save. And right up here it says Output PDF. So you want to make this into a file that's readable. I'm going to save it right here. This is like the one from Autodesk U. I'm going to put it on my desktop. Right there, hit save. And I have it so it opens the file up for me. Right here. Oops, wrong one. Right there. Just opened up. And it says drawn by me, scale, sheet, only one sheet. This will work just fine. This is what you want to submit or print out if you're making a part. So if you're submitting a file to me by PDF, it's easy to read. If you need somebody to make something and they're not even close to you, if you send them the solid model and the print's going to make it easy to me. I understand a lot more about it. Having both would be great because I can upload the solid model into my system and work on it. Okay, now in this case, I already did the print for the class. Right here, I did it August 13th. All right. So I have it with our own title block here. And I put in tolerance zone, aluminum plate, some notes right here. Now this is a little bit better because it's easy to read, but not too busy. Like here, this is the radius of the bolt circle. This is the diameter of the hole. Here's the overall length, and it's the spacing between the holes. So you're stacking the dimensions up here. These are like all coming from the same location. This is our 0 line. So 0, 0 would be up here. It's 1/2 inch over, and then it's 4.75. So you know how to get that whole pattern. And these are equally spaced. So I just describe one and say equally spaced. This one is 0.100, and there's 19 of them. So if you count these, and you're going to count for all of them. This one's 375, 5 places. So somebody should be able to make the part just using this, whatever method they're using.
You have 5 minutes left of computer time.
If they're out on the track mill, they can quickly write a program that cuts the circle, does the bolt pattern. If they're manual machining, they could drill the hole pattern. That would work fine. Or if you're writing manual G code at a machine, this is all you would need to do that. So drawings are a big thing. Understanding them and creating them as engineers or working in the shop. Okay, talk to you later.